All right, everyone. Today we are going to be doing Chapter 4, Section 6 on isosceles and equilateral triangles. First thing we have here is a little bit of vocabulary, and probably the easiest way to show what this vocabulary is with a picture. All of these words have to do with an isosceles triangle. So an isosceles triangle from Section 1, remember that's when two sides are congruent to each other. So I'll just say those two are the congruent sides to make this an isosceles triangle. Those two sides that are congruent, those are the legs. Those are the congruent sides. When we talk about the legs of an isosceles, they are the two sides in that triangle that are congruent. The vertex angle, that is the angle between the legs. Using some of that vocabulary from previous sections, we could call it the included angle between those legs if you wanted, but that's the vertex angle, the one where the two legs or congruent sides meet each other. And the last one, the base angles, those are the other two angles. And we call those the base angles because if you remember before, we called that third side that isn't congruent.
1205, please call 2330-1205-2330.
We called that side that isn't congruent to the other two the base. So these are the angles that are along the base. So here are our base angles right there and there. So that is the vocabulary today. Let's go on. So we have two theorems here for our isosceles triangle. Remember, two sides are congruent in this triangle because it's an isosceles triangle. The first one is the isosceles triangle theorem. It says if two sides of a triangle are congruent, that means you have a isosceles triangle. So if two sides of a triangle are congruent, then the angles opposite of those sides are congruent. So right here, we have our legs, AC and CB. Those two are marked as congruent, so those are our legs. So the angle opposite of side AC, that is the angle as far away from there as you can get while still being inside of this triangle. So in this case, angle 2. The angle opposite of side CB is the angle that's as far away from it as you can get, so in this case, angle 1. So our theorem says since these two sides are congruent, their opposite angles, 1 and 2, have to be congruent as well. So you can say those two angles are congruent to each other. Another way to find those opposite angles is they are the only angle that do not touch that side. So here's side AC, angle 1 touches it over here, angle C touches it here. The only angle that does not touch side AC is angle 2. So that is the opposite angle. Excuse me. Our other one here is the converse of the isosceles triangle theorem. Remember from earlier chapters when we were doing our converse, inverse, and contrapositive, the converse is the statement where the hypothesis and conclusion switch places with each other. So it's just the same statement, but the hypothesis and conclusion have switched. So this one said, if the sides are congruent, then the angles are congruent. It's going to switch to now say if the angles are congruent, then the sides are congruent. It still has to be those opposite sides. So looking at this picture here, we now know that angle 1 is congruent to angle 2. So the sides opposite of those, side as far away from angle 1 as you can get, is side FE. FE is opposite of 1. And the side opposite of angle 2 over here, side DE, is opposite of angle 2, so FE and DE have to be congruent. Again, another way to help you find those opposite sides is that it is the only side that does not touch that angle. Here's angle 1, is this side and this side. Those are the sides, or rays, or in this case segments, that make up that angle. FE is the only one that didn't make it up. So that's why it's the opposite side. Same thing here. FD and FE both make up sides of angle 2. DE does not, so it is the opposite side. So let's do a little bit of work with that. It says name two unmarked congruent angles. I know that this angle and this angle are congruent, but they're already marked. It says ones that aren't marked. So we need to try to use that isosceles triangle theorem that says if we have two sides that are congruent, the angles opposite of them are congruent. In this case, these sides are both in this bottom triangle, so we're only going to be working with sides in this bottom triangle. So the side opposite in this bottom triangle, the angle opposite, going as far away from that side as we can in that triangle is angle A. So I can say angle A is going to be congruent. And now this side is the other one that's congruent, getting as far away from it as we can while staying in this triangle. This angle touches it, this angle touches it, so the only one that's left to be opposite is this angle C out here. The only problem is if I just call it angle C, that could be the top half, the bottom half, or the whole thing. So we need to use 3 letters. So I'll call it ACB, angle ACB. Those two angles are congruent to each other because they are the angles opposite of those sides that are marked as congruent. All right, our next one, the exact same picture, but this time it asks to find 2 unmarked congruent segments. So that's the only difference, is this one's asking about segments. So to find congruent segments, these 2 are marked, but they don't want the ones that are marked. They want them to be unmarked. So we have to find congruent angles.
Brenda Martinez, please dial 2345. Brenda Martinez, 2345.
So you need to find congruent angles, which are right here and right here. These are both in the top triangle, so we're only looking at the top triangle. We don't care about this bottom part at all. To find the angle opposite of this angle C, we have to get as far away from it as we can inside that triangle. And I have segment BD, and that is going to be congruent to the segment that is opposite of this angle. So as far away from that angle D as we can while staying in this triangle is segment BC. Those 2 segments have to be congruent because they are opposite of these 2 angles that were marked as congruent. Be careful if there's more than one triangle in your picture that you are always staying inside that same triangle. All right, so this picture right here, just a little bit of extra practice. It says which statement correctly names 2 congruent angles. We have PJM, and PMJ. So that's talking about this angle right here and this angle up here. And we have to see, is there any way for us to know that PJM and PMJ are congruent? They kind of look like it, but if that were the case, we would need to know the sides opposite of them, like this side and this side, were congruent, and we don't. So it's not A. Angle JMK, this whole angle here, the whole thing, this whole angle, this corner, is congruent to angle JKM. So that's this whole angle on this side. Are those congruent to each other? If they were going to be, since it's the whole angle, we're just looking at the whole big triangle. If those 2 angles were going to be congruent, the side opposite of that angle, this one, JM, would have to be marked as congruent as the side opposite of this angle over here, JK. Are JM and JK congruent? Yes, they are. So our answer on this one is B. This one says which statement correctly names 2 congruent segments. To find congruent segments using our isosceles triangle theorem and its converse, we want to find congruent segments, we need to find congruent angles. Here's an angle and here's an angle that are marked as congruent to each other. These 2 right here. So let's find the sides opposite of them. As far away from M as I can get is PK. PK is right here. And as far away from K as I can get is PM. PK congruent to PM. Very good. Because they are the sides opposite of those angles that were marked as congruent, they have to be congruent. Now we're going to work with equilateral triangles. And equilateral triangles are actually way easier than the isosceles triangle, because in an equilateral triangle, all three sides are congruent. So if you know one, you know all of them. And if you have an equilateral triangle, you know all three angle measures as well. If it's equilateral, it has to have three angle measures that are 60 each, 60, 60, 60. And the reason for that is because if all three angles have to be the same, right here, they're equiangular, all three angles are the same, you have to have a number plus itself, like x plus x plus x. And since it's a triangle, it has to add up to 180. 3x equals 180. Divide by 3, and you find that each angle is 60 degrees. So this one here, if a triangle is equilateral, it has to be equiangular. Also, since it says if and only if, that means it works backwards. If you know all three angles are equal, are 60, then you can say all three sides are congruent as well. So if all three sides or all three angles are congruent, it's equilateral and equiangular. All three sides are the same, and all three angles are 60. In this case, it asks us to find the measure of angle R, this angle right here. Okay, well, from what we knew about our equilateral triangles, since these two sides are the same length, 5 and 5, that means by definition they are congruent. So this angle and this angle are congruent. So I can call them x and x. So I have x plus 60 is equal to 180. 2x plus 60 equals 180. 2x equals 120 by subtracting. Divide by 2, and I have x equals 60. So 60, 60, 60. This is an equiangular triangle. So that means even though it doesn't tell us, since all three angles are 60, that means all three sides have to be the same. So I can say right now that that has to be 5 centimeters. So now that I found out that it is equiangular, I know that it also has to be equilateral. This only asks for the measure of angle R. Measure of R is one of the angles of my triangle, so it is 60 degrees. Always make sure you actually answer the question that is asked. This one right here asks us to find PR. Well, we just figured out that all three angles were 60, which means all three sides are congruent. We already explained that on the last side, so it has to be 5 centimeters. Same picture, so whatever we talked about there still works. All right, this one asks for the measure of angle T. I know that these two sides are the same, so they are by definition congruent, which means the angles opposite of them have to be congruent. If this one's 60, so does this one. So the measure of angle T, this angle, has to be 60 degrees. If these two are both 60, that does mean this one up here is also 60 degrees. So this is an equiangular triangle. 60, 60, 60 adds up to 180. These two are both 3.5, so our last side would also have to be 3.5, which, if I remember correctly, is what this question asks. TS has to be 3.5 because, as we just showed, if these two sides are the same, it means these two angles. So this is an equiangular, equilateral, so it has to be the same as those. All right, the last kind of thing we're going to do today is working with setting these up to solve for some variables. Right here I have this side marked and this side marked as congruent. So that means their measures are equal. So I can do 6y plus 3 is equal to 8y minus 5. And now it's just algebra from there. With my angles, I have 4x minus 8 and 4x minus 8 for that angle. If those are both the same, the third one has to be the same, meaning each of these is 60. So I can say 4x minus 8 equals 60. And then from here, it's just algebra, so I'll work that out. Subtract 6y, I get 3 is equal to 2y minus 5, add 5 to both sides, and I have 8 is 2y, divide by 2, and get 4 is equal to y. I'll use my symmetric property to say y is 4. Here I add 8, 4x equals 68. Divide by 4, and I get x equals 17. Yeah, 40 and 28. It asks for the value of each variable. I found it, so I'm done. Always make sure you read. It might have asked for this side length, and I would have had to plug it in, or something like that. So always make sure you read the question. Here's the same idea. Our last example, each angle has to be 60. So 3x equals 60. Divide by 3, and we get x equals 20. So I know x is 20, so C and D are out right away. And then I know these two sides have to be equal. So I can say 2y minus 6 equals 8. Add 6 to both sides. 2y equals 14. Divide by 2 and get 7. Alright, this is the homework. You can pause the video here and write it down. You can find it off of Canvas. The slides are already loaded there. This is going to be collected, well, I guess it's due on Tuesday, but remember that we have a test on Tuesday, so realistically you want to have this ready to go for Monday, but if you don't have it till Tuesday, that's okay. But it would definitely be in your best interest to have it ready for Monday. All right, have a good day.